In today's class, we will be dealing about the second type of S matrix problems. In the previous video, we have seen the first type of S matrix problems wherein you will have a given network and you will be calculating or estimating what is the S matrix of the given network. In today's session, we will be talking about a place wherein you are given a S matrix and you are going to analyze the network. So given an S matrix, so this is a 4-port network, that's why we have a 4x4 S matrix. So we are going to analyze the network. The first question that is available is the network lossless? And second is the network reciprocal? What is the return loss at port 1, what is the insertion loss and phase delay? What is the reflection coefficient at port 1? These are the various kinds of questions that could be available. So let's take one at a time and let's solve the problem. The first problem is the network lossless? So the first question is the network lossless? So you are given an S matrix and you are asked to find out if the network is lossless. Okay. So the first thing that you will have to understand is this is the magnitude of the S11 component and this is the phase of the S11 component. This is the phase and this is the magnitude components. This is the phase and the magnitude component. So why we have a 4x4 matrix? That means this network has a 4-port network. It could be a circulator of 4-port or what you call it as a 4-port circulator. So the first thing that we are going to show is we are going to prove that the network is, or find out whether the network is lossless or lossy. So if you can recollect from your previous sessions, you know that for the condition for a network to be lossless is that it should satisfy the condition S star transpose into S is equal to identity matrix. So the condition for the network to be lossless is S star transpose into S is equal to identity matrix. So I have a S matrix. So let's find out what is S star transpose of the matrix. So if you need to write the S transpose of the matrix, it's nothing but converting the rows to columns and columns to rows. Now look at this. You have 0.1 angle 90, okay, and then you the second fellow is 0.8 angle minus 45. That's what is written here because I am also taking the complex conjugate. And the third fellow is 0.3 angle 45. It becomes 0.3 angle minus 45. The fourth element is 0. The second row is 0.8 angle 45, 0.8 angle minus 45, 0. Third is 0, and then 0.4 angle 45 becomes 0.4 angle minus 45. Now let's go to the third row. It's 0.3 angle 45, it's 0.3 angle minus 45, 0, 0, 0, 0, and 0.6 angle 45 becomes 0.6 angle minus 45. And similarly, you can write the fourth row. It's here. So we have written the S star transpose of the S matrix. So what is transpose? Transpose is converting the rows to columns and star is taking the complex conjugate. So we have done both those. So we have calculated S star transpose. Multiply with the S matrix. So what is the S matrix? This is the S matrix. We have repeated it here. So now if you multiply this S star transpose into S matrix, so if we do a matrix multiplication wherein you multiply this row with this column, you will find that the S11 element is 0.74. S12 element becomes that is this fellow with this fellow. If you multiply, you will get 0.056 minus angle 45. This fellow with this fellow, you will get 0.212 angle minus 45. And similarly, you do a 4x4 matrix multiplication. This is your final S star transpose into S. Now look at this element. Is it a unitary matrix? It's definitely not a unitary matrix. So a unitary matrix is, where you have only your diagonal elements to be there, all the other elements will be 0. So this will be the unitary matrix for a 4x4, this is a 4x4 unitary matrix. So we do not get a matrix like this. So naturally this network is not a lossless network, it is a lossy network. So S star transpose into S is not equal to I, which means the network is a lossy network. The next thing that we will be seeing is we will be finding out if the network is reciprocal or not. So To find out if the network or estimate if the network is reciprocal or not, we will have to use this formula. We have discussed it in our properties of S matrix. If S is equal to S transpose, if S is equal to S transpose, then the network is reciprocal. Then the network is reciprocal. So let's take the S transpose of this matrix. Let's write the S transpose of the matrix, which is nothing but converting your rows to columns and columns to rows. But by looking directly into the S matrix, another way is, above the diagonal and below the diagonal, the matrix looks alike. So naturally this is a reciprocal network, but let's write the S transpose of the network. So converting the rows to column, 0.1 angle 90, 0.8 angle 45, 0.3 angle 45 and 0. This fellow I'll have 0.8 angle 45, 0, 0, 0.4 angle 45. And the third row I'll have 0.3 angle 45, 0, 0, 0.6 angle 45. And the fourth row I'll have 0, 0.4 angle 45, 0.6 angle 45 and 0. Now let's compare both these elements, S and S transport. Are they alike? Yes, they are exactly the same. So when you convert the rows to columns and the rows to columns, S is equal to S transpose. So the network is reciprocal. The network is reciprocal. This is the second inference from the S parameters. This is the second inference from the S parameters. The third inference that we are going to find out is what is the return loss of the network. What is the return loss of the network? What is the return loss at port 11 when all other ports are terminated with matched loads? What is the return loss at port 11 when all other ports are matched with its matched load? To find out this, we use the formula gamma is equal to 1 minus modulus of S11 squared. We are interested in finding out what is the return loss at port 11. So it is 1 minus modulus of S11 squared. So if you take this, you will get the reflection coefficient. So what is it? 1 minus modulus of S1 squared will be nothing but 1 minus, what is S11? 0.1. So 1 minus 0.1 whole squared. So which will be nothing but 1 minus 0.01. So it is not even enough if we find the reflection coefficient, we will also have to find out what is the return loss. So if you have to find out the return loss is nothing but minus, so if you take this is nothing but 0.99. So minus 20 log of 0.99. So if you compute this, you will get the return loss at port 111 when all the other ports are matched with its matched loads. So if you take minus 20 log of 0.99, you will have the answer to go to 0.08 dB. And why have I put the minus sign? Why have I put the minus sign? Because it is representing loss. It is representing loss. So that is why I put the minus sign. And why have I put 20 log? Because you know that this is nothing but your S11 represents your RMS voltage. So that is why we have 20 log. So minus 20 log of 0.99. So this is the third parameter that we are computing. So next move on to the next fellow. What is the insertion loss and phase delay between ports 2 and 4 when all other ports are terminated with matched loads? What is the insertion loss? What is the insertion loss between ports 2 and 4 when all other ports are terminated with matched loads? So we are trying to find out the insertion loss between ports 2 and 4. If you go back and recollect the S parameters, let me just do it in a small way. Let's take a two-port network. I have, just to give you a quick understanding, this is A1, B1, A2, B2. S11 was nothing but B1 by A1. S21 was nothing but B2 by A1. So what is, this is nothing but your gamma reflection coefficient. B1 by A1 is nothing but the reflected by incident wave, so it represented your reflection coefficient. Whereas S21, which is B2 by A1, represents your insertion loss. Represents your insertion loss in a passive network. Suppose if you have an amplifier or an active network, then it may represent something called as gain. But B2 by A1 is nothing but the insertion loss inserted by the network. So if S21, this is for a two-port network. So what we are trying to find out is we are going to try and find out the insertion loss between port 2 and 4. So port 2 and 4, what is the input port? S42. So that is what we are going to, because see, if you have a two-port network and you look at it, B2 by A1 is nothing but S21, which is nothing but your insertion loss. 1 represented your input, 2 represented your output. In this case, we have between 2 and 4. So what will be the output? S42. So what is S42? S42 is nothing but what is the insertion loss and phase delay between ports 2 and 4 when all other ports, so insertion loss S42 will be nothing but S12, what is 42.4, 0.4, this is your S42. S42 is 0.4. This is the insertion loss. Again, when I say insertion loss, we'll have to compute minus 20 log to the base 10 of 0.4. So if you take minus 20 log to the, you'll get 7.95 dB. This is the insertion loss of the network, 7.95 dB. Alright, so this again, this minus sign is to tell you that this is an insertion loss. But one thing which you'll have to find out to see, this is, we have computed the insertion loss now. That is also called as a phase delay. So what is the phase delay? Phase delay is nothing but this 0.45. So phase delay is 45 degree. Phase delay is 45 degree. So this is the insertion loss and phase delay between ports 2 and 4 when all the ports are terminated with matched load. So the last question is, what is the reflection coefficient seen at port 1 when a short circuit is placed at terminal plane of port 3 when all other ports are terminated with matched load? So first thing what we will see is, we will see what a reflection coefficient is. Just a recap for a second of what reflection coefficient. Let's say a two-port network, and if you need to find out the reflection coefficient, what we call it as A1, B1, this is A2 and this is B2. B1 by A1 will be your input reflection coefficient. B1 by A1 is nothing but your input reflection coefficient, which will be given by gamma in is equal to S11 plus S12 S21 gamma L by 1 minus S22 gamma L. So this will be your input reflection coefficient. Suppose if you want to compute the output reflection coefficient of this fellow, gamma out will be nothing but B2 by A2, which is given by gamma out is equal to S22 plus S12 S21 gamma L by 1 minus S22 gamma L. So this is the general equation for calculating the reflection coefficient, whether it's input reflection coefficient or output reflection coefficient, all these things. So here we have a different condition where we want to find out the reflection coefficient between port 1 and port 3. But before we jump onto this, we will address what is this gamma L value. We will find out what is this gamma L value. See, this gamma L value is nothing but the reflection, right? So what will be the maximum value of this gamma L? We know that, we are all using matching networks. All these matching networks are nothing but passive networks. So the maximum value gamma L can take is 1. What is the maximum? When will gamma L be maximum? Under a short, if you can recollect in a Smith chart, if you go back to your Smith chart, you could recollect that in an open circuit condition, gamma L will be nothing but 1 angle 0. Gamma L will be 1 angle 0, and in a short circuit condition, gamma L is equal to 1 angle 180 degree. So this is the maximum value that gamma L can take. Why? Gamma L itself is nothing but gamma L is what? Reflected wave by incident wave. So the incident wave is the energy entering into the system, and reflected wave is part of the energy gets reflected back. So naturally the reflected wave will be greater than the incident wave on any, the incident wave will be greater than the reflected wave in any condition, because we are dealing with only passive networks. So that being the case, naturally gamma L value should be always less than 1 or equal to 1. There are only two conditions when gamma L value can be equal to 1. That is on an open circuit condition where gamma L is equal to 1 angle 0 degree, and the short circuit condition when gamma L is equal to 1 angle 180 degree. There is another condition. What will be the gamma L value when a matched load or in this case, when there is a matched load Z0, what happens? All the input signal will be absorbed by the load. So there will be no signal that gets reflected back. So what happens to gamma L? Gamma L will be 0. Gamma L will be 0. So these are only three values gamma L can take here. So what are the three values? 1 angle 180 in short circuit condition, 1 angle 0 open circuit condition, 1 angle 0 in matched load condition. 0 in a matched load condition. These are the only three possible values gamma L can take. So let's go back to our problem. In our problem, we will have to find out what is the reflection coefficient seen at port 1 when a short circuit is placed at the terminal plane of port 3. So what will be gamma? Gamma will be nothing but S11 plus S13 S31 gamma L 1 minus S33 gamma L, because we are not interested between port 1 and port 2, we are interested between port 1 and port 3. And what is the gamma L value that we will have here? Gamma L is clearly given, it is a short circuit. So gamma L will be 1 angle 180, which is nothing but it is equal to minus 1. Gamma L will be 1 angle 180, which is nothing but is equal to minus 1. So this is equal to S11 is what? S11 is, let's substitute these values. So S11 is 0.1 angle 90 plus S13 is, what is S13? 0.3 angle 45. S31 is again 0.3 angle 45. Gamma L is 1 angle 180, so which is nothing but minus 1 by 1 minus S33 is 0 minus 0. So if you solve this, you will get the answer 0.01 angle 90, which is your gamma, the reflection coefficient. Alright, so just a recap of our problems. First thing is, whether a network is lossless, S star transpose into S should be equal to identity matrix to show that the network is lossless. To show a network is reciprocal, it should satisfy the condition S is equal to S transpose. Third, to find out the return loss, you have the condition 1 minus S11 squared, but please make sure that you take minus 20 log to make sure to calculate the return loss. And similarly, what is the insertion loss between ports 2 and 4, you will have S42. So 0.4 will be the insertion loss, magnitude of the insertion loss, and 45 degree will be the phase delay. And to find out the reflection coefficient, we have this formula. Alright, so but remember, when we take loss, always take the minus 20 log of that value to compute the loss of the network. So this is the second type of problem where we have the S matrix and we are asked to characterize the properties of the matrix.